Hello friends, in this video lecture we are going to continue with our endeavor to solve all the questions from mid-course test General Navigation Oxford. In this video lecture we will be solving the last set of questions remaining, that is question 41 to 50, and I hope you have understood all the questions that I have done in the previous video lecture. I also hope that you understand all the 10 questions that I will be doing today and have fun. So let's start with question number 41. A pilot receives the following signals from a VOR station: radial 180, accuracy plus minus 1 degree, distance 200 miles. What is the approximate maximum error? That means we have to calculate cross track distance, distance off track, right? So this is your VOR. There is a radial 180 emanating from this VOR, but the accuracy of this station is plus minus 1 degree. So when you expect to get radial 180, you may erroneously get a radial or a reception of radial 181 or 179. So let's say you get a reception of radial 181 instead of 180. We have to calculate the distance between them, the maximum distance, cross track distance between them at a distance of 200 miles. A long track distance is 200 miles. We have to find the cross track distance. Okay, angle is 1 degree. Now let's use 1 in 60 rule formula. 1 degree equals to distance of track, which we have to find out. Distance gone into 60. So 1 degree equals to distance of track divided by distance gone, 200 into 60. So distance of track is equal to 200 by 60, which is equal to 3.3 nautical miles. 3.3 nautical miles. Let's use tan theta formula. So tan theta equals to opposite upon adjacent. So tan 1 is opposite, we have to find out. Adjacent is 200. So cross track distance equals to 200 into tan 1, which is equal to 3.5 nautical miles. So 3.3, 3.5 more or less same. So correct option will be Bravo, plus minus 3.5 miles. Let's go to question 42. Aircraft has planned to fly from A to B, a distance of 135 miles. So A to B, a total distance of 135. After flying 45, the aircraft is 3 miles left. Next, using 1 in 60 rule, what would be the alteration of heading to fly directly to B? So when we have to fly directly to B, we use track error and closing angle method. So, okay, track error and closing angle method. Let's first focus our attention on this side of the triangle. Let's find track error first. Track error is distance of track by distance gone into 60. So 3 divided by 45 into 60. So 3 into 60 divided by 45 is 4. So track error angle is 4 degree. So this angle will also be equal to 4 degree. Okay, corresponding angles are equal. Next, let's find closing angle. Closing angle is again distance of track divided by distance remaining by multiply 60. Now distance remaining. What is total distance? 135. Now 135 minus 45 is equal to 90. So remaining distance is 90. So 3 by 90 into 60. 3 into 60 divided by 90, which is 2. So closing angle is 2 degree. 2. So now final alteration in heading. So let's write it here. The alteration of heading will be equal to 4 plus 2, that is 6 degree. To what side? Right hand side or starboard. Okay, so alteration of heading will be 6 degree to the right hand side. Let's go to next question. By what amount must you change your rate of descent if there is a 10 knot increase in headwind on a 3 degree glide slope? Now during your descent, headwind influences your rate of descent. That is how fast or how quickly you descend, okay, or you come down. So that influences your rate of descent. Increase in headwind increase in headwind speed will increase your rate of descent. Means if headwind increases, the speed of headwind increases, the rate at which you are coming down or descending will also increase. That means you will come down at a much faster rate. Okay, will increase. So increase in headwind will increase rate of descent. So you do not want this situation. You want a constant rate of descent as you follow a 3 degree glide slope. So if headwind tends to increase your rate of descent, what will you as a pilot do in order to counteract that or cancel that effect of headwind? You will have to cut engine power a little more, okay, so as to decrease the rate of descent. Okay, so both gets balanced. Headwind tries to increase rate of descent. You're preventing that by cutting down engine power or doing something else, and hence arresting that increase in rate of descent. Okay, so increase in rate of descent, increase in headwind, increase in rate of descent. So this is the problem. The solution to that is pilot pilot should decrease, should anticipate that there is increase in headwind. So he must anticipate that very soon or very quickly rate of descent is going to increase. So he should decrease his rate of descent. So this is the solution. Okay, so should decrease his rate of descent. Now, how much? By what value should he decrease his rate of descent? The formula is the change in rate of descent equal to change in ground speed into phi. Now, the change in speed is what? 10 knots increase. So, change in ground speed is 10 knots into phi. So, 10 into 5 is 50 feet per minute. So, final answer, by how much must you change your rate of descent? So, final answer is the rate of descent must be decreased by 50 feet per minute in order to continue maintaining a 3 degree glide slope in face of 10 knot increase in headwind. You are on an ILS 3 degree glide path which passes over the runway threshold at 50 feet. So let's say this is your runway. Okay, and this glide path passes over the threshold of the runway at a height of 50 feet. Okay, the glide path will touch the runway in the touchdown zone. Over the threshold, it is 50 feet. Your DME range is 25 miles away from the threshold. So you are 25 miles away. So 25 miles is nothing but 150,000 feet. What is your height above the threshold elevation? Above the threshold elevation using the 1 in 60 rule. So you have to find aircrafts. Aircraft is here. To find the height of aircraft from the threshold. Okay, that is from the ground level. Now, so that will be equal to, first we will find this height with respect to this glide slope. And then we will add this extra 50 feet. Okay, that will be the height of aircraft from the threshold. So now this is a 3-degree glide slope. The distance is 150,000. You have to find this height, this vertical distance. 3 degree equals to distance of track, that is height, divided by distance gone, that is 150 into 60. So distance of track or height is equal to 3 into 150,000 by 60, which is equal to 7,500. So height of aircraft is 7,500 with respect to this glide slope up to this point. We have to find height from the threshold, so we will have to add another 50. So 7,500 plus 50 is equal to 7,550 feet. So the height of aircraft above the runway threshold is 7,550 feet. Next, question 45. Aircraft flies directly from 56 north 20 west to 56 north 30 west. So this is one longitude, this is another longitude. Both locations are on the same latitude, that is 56 north. This longitude is 20 west and this is 030 west. Right, flies from 20 west 30 west longitude. The initial great circle track from 020 west is how much? Since it's northern hemisphere, the great circle track will pass from the nearest north pole. This will be your rhumb line. Very simple. Now rhumb line track, let's call this place A, this place B. The rhumb line track from A to B is 270 westerly direction. So A to B. For rhumb line track B to A will be 090. Next, we have to find great circle track at A, this angle. This great circle track at A is made up of rhumb line track of A up to this point and plus this additional small angle which is your conversion angle. Now what is convergency? Convergency is d long in degrees into sine latitude. Now the d long is 20 minus 30, 10 into sine of 56. So 10 into sine 56 is 8.8 degree. Therefore, conversion angle will be approximately 4 degrees. Great circle track at A will be Ramline track at A270 plus convergency angle 4. So that amounts to 274 degree. Simple. Next, question 46. Aircraft starts at this position and tracks north for 2,950 miles, then turns 90° left and maintains a Ramline track for 314 kilometers. What is the final position? Let's say A to B, the distance is 2950. Location A is 4 degree 10 minutes south. Location and longitude is 178 degree 22 minutes west. So what will be the coordinates of position B? Since it's a northerly direction flight, A to B is northerly track. So we will use great circle formula. Great circle distance equals to difference between two latitudes into 60. So 2950 nautical mile equals to d lat into 60. So d lat will be equal to 2950 by 60 is equal to 49 degree 10 minutes. Right? Now let's draw the earth. This is your earth. This is the equator. Your initial latitude is 4 degree 10 minutes south. You're flying north. Cross the equator and enter the northern hemisphere over here. Okay, so what will be your new latitude? So this difference, the difference between equator and 4 degree 10 minutes south is 4 degree 10 minutes. The total difference is what? Total d lat is equal to 49 degree 10 minutes. Out of that total 49 degree 10 minutes, we have traveled 4 degree 10 minutes in the southern hemisphere. So d lat is nothing but initial latitude plus final latitude or new latitude. So 49 degree 10 minutes is equal to 4 degree 10 minutes plus new latitude. New latitude will be equal to 49 degree 10 minutes minus 4 degree 10 minutes, which is equal to 45 degree. 45 degree. So new latitude will be 45 degree north. 45 degree north. Okay. So 45 degree north. Longitude will remain the same. 178 degree 22 minutes west. Now from this location Bravo, we turn 90° left and maintain a track for 314 kilometers. So we turn left, maintain a track of 314 kilometers, divide by 1.85, which is equal to 170 nautical miles. And now we have to find new coordinates of location C. Now since we are flying on the same latitude, the latitude is going to remain the same, 45 north. What will change is longitude. So now here we will use Ramline distance formula, d long in minutes into 60, which is equal to 170. So d long in minutes equals to 170 by 60, which is equal to 2 hours 50, 2 degree 50 minutes. right? Now, the new location or new longitude will be initial longitude minus d long. So you make a 90-degree left turn. 90-degree left turn. So this is your Earth. This is the North Pole. This is your prime meridian. This is your 180-degree anti-meridian. Now all westerly directions are clockwise and easterly directions are anti-clockwise. Now here you fly northerly direction, then you make a left turn and fly 90-degree left. That is nothing but westerly direction you're flying. When you make a 90-degree left turn, you're making flying in a westerly direction. Westerly directions are all clockwise, right? So this is your initial longitude 178 degree 22 minutes west. From this longitude, when you make a 90-degree left turn, you fly westerly heading. So your new longitude will be somewhere to the right hand side of 178 degree 22 minutes. Right hand side means the value will be more than 178 degree if the new longitude is in the western hemisphere. If it crosses 180 degree anti-meridian and enters eastern hemisphere, the value will be less than 180 degree east meridian. So new longitude will be initial longitude plus the D long. So 178 degree 22 minutes plus 2 degree 50 minutes is equal to 181 degree 12 minutes minus 180 degree. So what you do is subtract 180 degree from this. Okay, then you get 1 degree 12 minutes. So that means you have entered eastern hemisphere. Okay, and the new longitude will be somewhere here at a difference of 1 degree 12 minutes from 180 degree. So 180 degree minus 1 degree 12 minutes again will give you a final answer of 178 degree 48 minutes east. Okay, so you have to select the option which has this value or any value close to this. So what will be the new final position? It will be 178 degree 48 minutes east. Let's go to next question 47. On a chart, 49 miles is represented by 7 centimeters. What is scale? Scale equals to distance, chart distance upon earth distance. Now chart is 7 centimeter. This is 49 nautical miles. 7 centimeter divided by 1852 meter. Meter into centimeter is 100. Okay. So, so 7 . 49 into 1852 into 100. So 7 divided by 9074800. So again divide numerator and denominator by 7. You get 1 divided by 1296400. So this is the final answer. Scale is 1 divided by 1296400.